morning, ladies and gentlemen. I'm here to talk a little bit about real global warming for the new low GWP refrigerants, because if you have noticed, there is some different values out there. Sometimes you see, for example, the very used, let's get this done, thank you. You see values about 7 or 6, 7 for the 1234 ZE. Sometimes you see it's less than 1. So what is up and down in this? So this is what I'm not going to talk about compatibility with materials, because that's a totally different topic. Global, what happens here? Global warming is only one point of many when we are discussing refrigerants. We are also talking about safety. We are talking about system efficiency, and we are talking about environment and all the points between this. And this discussion here is a little bit more over in the corner of the safety and perhaps a little bit about training and this kind of things, design for the system. But there's a lot of ways to look at refrigerants. You also look at LCCP, life cycle cost, performance, and all these kind of things. And in the middle of everything, there's also legislation as another point. Let me tell you a little bit about refrigerants. They are classified in different ways. I've tried here to reflect a little bit the Montreal Protocol. You have the chlorine-containing refrigerants to one side, and only the fluorinated on the other side. Funny enough, one of the new low GWP refrigerants you see in the market, 1233 ZD, is actually an 8 CFC. So how can that be part of the solution, if it is part of the solution? But it is because the ozone depletion level is so small, so at least at the current use, it doesn't mean any disturbance. Where we have the green box to the far right, it is the one component low GWP refrigerants. There is a number of those out in the market now. The most famous is 1234 YF and 1234 ZE. And then there's some other ones used more for heat pumps, 1336 also. All the others are blends, which is quite important to know, and those blends contain primarily, if they are in the lower region of the GWP, they contain R32, and I will come back a little bit to the problem with 32. Here we have some values, and also I can see the blue over what you call this color is snatched out or snitched out of the unit fact sheet, and it says that R290 has a global warming potential of 5, and that's a mistake. I'm sorry to say, Albert, but it's a mistake, because it has not been for many years higher than 3.3, and that is only part of the truth. Because when we look at the GWP values for the HFCs and CFCs and all this, it does not contain the breakdown products. It is worth noting. And then you compare that to HCs, where the breakdown products are included. So putting them in the same table and trying to say that it is comparable, this is even a worse mistake. So what I've tried here is to look at 1270, which is the hydrocarbon from which the new low GWP refrigerants are derived. I've tried to put them in the same what do you call it, spreadsheet exercise, where we can see that the global warming potential in 100 years for 1270 without breakdown products is in the range of 10-fold lower than for many of the HFCs. And now we're comparing apples to apples and not apples to bananas. 1270 has a lifetime in the atmosphere of a few hours, and that is why it has a GWP, as you see here, is extremely low. 1270, if you look on the 100 years with the breakdown products, has a GWP of 1.8. Where do I know this from? It is from assessment report 4. Another thing is these low GWP refrigerants. As VMO, they have put it in one of their newsletters. They say that it forms a TFA, and at the current uses, it doesn't disturb anything. That is in the current use number, because it's still down in commercial releases. It's not in industrial production yet, to my knowledge, but that can be changed. The TFA has been in the nature forever, but that is formed by the stones on the beach, where stones are grinded and the fluorine is coming out in seawater, and it doesn't go up and disturb anything. Before, we didn't find TFA in sweet water, in groundwater, but now we start to see it, and it is not from the new HFCs or HFOs if you want, but it is from the old ones where the breakdown products actually end up in the sweet water. And that is where it comes from, because the stones in rivers, in lakes, they don't grind the same way as you do on the beach, where it is 24 hours a day. What comes out of the breakdown products, and this is where the safety comes into the picture. In the machine room, you can have various breakdown products. You have 2 columns of breakdown products. It's the intermediate that are one of them. And one of these, it's called HCHO. As some of you perhaps know, this is formaldehyde. And formaldehyde is not extremely healthy. It's not a vitamin, I have to say. It is, and the safe, what we call short-term exposure limit, is down in few ppm, closer to 0. It's about 2 ppm. We can choose to put in sensors to detect this in the machine room, but where do we place it? And that is another thing. When I ask the scientists that have made these global warming potential values, what is the global warming of all these breakdown products, they say it's too difficult to calculate, so they don't give it. That is the reason that we don't have it. And actually, we don't know what is the global warming potential of the low GWP refrigerants. We know what the pure product before breakdown is, and that's it. Everything else we don't know. And that is very dangerous. And what we see out in the far end column, it is the breakdown products that stay in the nature. But we have no guesses on the proportions or how much of it is. Of course, one day it will be dissolved in water, but in dry climates, or here in Beograd, if you have a big release in the center, in a period of no winds, it would participate in smog. If these breakdown products chemically go into combination, or what you call it, react with organic compounds, because we don't know what is out in the atmosphere nowadays, then you get really, really bad and unhealthy products out in the air. Another thing is, I know you cannot read, and so can I not, read the table to the left, but it is some of all the HFC refrigerants I found on the latest version of Chilventa here in October here. I tried to put them into different groups because we are now facing the Kigali Amendment, and where do we go with that? I showed the other day a slide where we could see how it varies with the growth rate in the market, what we will end up with in the end. So we can say if we have something below 150, we are on the safe side, because that is what is given in the MAC directive. And there you have some few refrigerants for different working areas. You have for R22, you have R457 and 454, and all these down here. It's not very many now, out of 80. Remember, there is about 80 different blends out in the market at the moment. I'm not calculating the HC solutions in this context. And then you can see over 400 and up to about 999, there is a number of blends, but I don't see a long-term, if we look at the current legislations, which we know, and the average GWP that will come out of that, we will not have the possibility of using more than 400 in the long term, at least in the EU. I'm coming from an EU country. So this is with what we will actually be seeing in the future. Then we can say what is really low GWP, and there has been some different ways to scale it. The left one table, the left table is from an RTOC report from 2010, which gives a good guideline. But with the new life, with a lower, we have to change the scale, and I found this left scheme, or where you can see it's a little bit different. 161 is also HFC, but with a global warming potential of about 12. Now, this 1200 series are derived out of 1270, but it's much more complicated than you think at first sight. In the good old days, we had one or two derivatives of, for example, 134, we had 134A, and that was what it. But now we are looking at, for example, 1234. We have 7 subversions of 1234. We have of the 1225, we have 4, and you can go on the 1224, which is also a suggestion from some companies. You have another 13 subdivisions. So I have a problem of showing this. I don't know exactly how Excel works, how we can make a 3D, because it would be a multi-sided kubus. I don't know exactly how to. How do we deal with the safety around this? One of the ways is to use the current standards, where the machinery room is enclosed, so you cannot go into the machine room. You can only put in your hands, but very few of us breathe with their hands. So in this way, we are in safe distance of what can be dangerous. And this box is ventilated to somewhere safe. There is a little ventilation, you cannot see it here. And then we can use all the standards for calculating the leaks. We can to measure the flammability issue, and how many leaks you have, and all these kind of things. And there is this emergency ventilator, as I have pointed out over to the right of the pictures. It's all in standards. We just have to use the standards that are already in place. So it's not so very difficult, it's just knowing these kind of things. But these slides, these 2 pictures here have been out on the UNEP page since 2010, I think it was. I said R32 for a second ago, and here you can see the red line is how the development in the atmosphere is now in terms of the concentration of R32. Remember that R32 has an atmospheric lifetime of 5.5 years. So how come that it already is growing? And it's because it's a part of different blends. For example, 410A is halfway 32. And many others, 407 series contain R32. In this way, you can see the concentration of R32 is growing into the skies. And I guess in a few years' time, that R32 will be part of a kind of phase down scenario as well, because it is starting to be disturbing to see this. So here we have the propylene GWP with breakdown products. As I said before, we don't know what it is. It has not been possible to calculate it out of public available data, what it is with the breakdown products, but without, you can see the global warming potential of 1270 is much lower than for the alternatives. So be careful when you see the different values out in the then you can discuss 20 years or 100 years. It is perhaps more relevant, as Greenpeace have also been out saying, but the regulation as it is now is built up on the 100 years, and let's deal with it as it is. Just we know what we are talking about, it makes it a lot easier. About safety again, alarms, they trigger at a certain level, but you don't know if it is just above this trigger level or is it very much over. That is very dangerous, and therefore we will start to push for a change a little bit in the standard, so we get a monitor so we can see what is it, rather than just trigger an alarm and we don't know where we are, because the alarm doesn't tell you. And also it goes for all refrigerants, it goes also for ammonia, where the filter mask, the filters are only designed for IDLH. They are not designed for 5,000 ppm or anything. They are designed for 300 ppm, that's it. It's very dangerous if you think that you are protected with a K3. You can go and work and open a compressor, you can take a blow out of ammonia in the face without getting problems, but you cannot go in, and you must not go into a concentration of 5,000 ppm with the filter, because it is not designed for it. If you have a breakthrough, you will, out of panic, pull off the mask, and then you get about 0.2 seconds and you're dead. But of course it's a quick one. So safe handling is very important of all refrigerants, including the low GWP gases. No gases are healthy, not even air, because if you go diving with air in your bottles and you go below 20 meters, those who know about diving, they know atmospheric air becomes toxic. Standards are in place to handle all this, so it's just to use them. And the long-term impact is for the generations after me, because I'm close to retirement, but it will come sooner or later. And many initiatives are already going on to look at the safe handling of also the new refrigerants. I know that ASHRAE in the US have initiatives coming up with this, so let's see what comes out of that. Thank you very much for your attention.